In the previous video, we looked at flow of control, pattern matching, and optionals in Swift. In this video, we're going to take a look at the changes to the Swift language as introduced during Apple's WWDC 2015 conference. We'll take a look at changes to enum, option sets, pattern matching, guard, availability checking, and more. Swift 2 enhances enums with associated value types. Now cases we specify can have associated values of any type, rather than a simple integer value. This allows us to define a common set of related cases and useful values as part of one enumeration. Swift 2 also affords us the ability to write an either associative enum. This gives us the ability to assign any two types and let our enum handle our values depending on the type it's been given. Swift 2 also introduces recursive enumerations. A recursive enumeration is an enum that has an instance of the enum as an associated value for one or more of the enumeration cases. Prior to Swift 2, if we tried to create an enum value that recursively called itself, we'd wind up with an enum of infinite size and our program would crash. However, in Swift 2, you can simply label a recursive case as indirect and it works as you'd expect. Option sets are a lightweight and efficient way to represent a set of booleans. In this example, we're using a C-style syntax to OR our options together. In Swift 2, the syntax has been updated as a square bracketed encased, comma-delimited list of options. Defining an option set is simple. We just create a struct and make it conform to option set type. Now we can give it a raw value to hold our bits and define the elements that we want for our option set. In the previous video, we discussed optionals and how unwrapping multiple option bindings will lead us to a pyramid of doom situation. The problem is that when successfully unwrapped, the unwrapped value is only available within the if-lets success block. Swift 1.2 tried to resolve this issue by introducing compound if statements. But this still wasn't the ideal solution. Swift 2 makes our lives easier by introducing guard. Guard does things differently than if-let. When an unwrap is successful, rather than enclose the unwrapped value, the value is released to the rest of the scope. In this example, we see a pyramid of doom situation with an if-let statement. If we replace our if-lets with guards, our code is dramatically cleaned up. That said, if a guard statement fails, you must exit your current scope by either using a return, a throw, or a break inside the else statement. Additionally, if you're using guard within a loop, you can use the continue keyword. In the previous video, we looked at several examples of pattern matching using a switch statement. But sometimes switches are a bit heavy-handed for smaller tasks. To accommodate these situations, Swift 2 introduces pattern matching for the other control flow statements in the language. So now, instead of using a switch to match on a single enum case, we can use something like this. For-in also received this capability. Now, we have the ability to loop through an array of enum values and pattern match directly within our for-in loops like so. Swift 2 adds built-in support for checking API availability, which ensures that you don't accidentally expose an API that's incompatible with the current operating system. Here's what an availability check might look like. If an availability check fails, Swift will report an error at compile time. Extensions give us the ability to take any given type, say string for example, and extend its functionality in such a way that it feels like a native part of the language. Swift 2 also gives us the ability to extend entire types. For example, we could extend collection type in precisely the same way we did with our string. We'll be writing our own extensions in Section 2, Advanced Language Features. Prior to Swift 2, do was a reserved keyword that was used in conjunction with a while loop. The do keyword has been replaced with the keyword repeat for clarity. The do keyword hasn't gone away, however, it's just taken on a new meaning. In Swift 2, the do statement is used to introduce a new scope that can optionally contain one or more catch clauses, which themselves contain patterns that match against error conditions. To be clear, variables and constants that are declared within a do statement can only be accessed within that scope. Swift 2 moves away from the traditional Objective-C way of error handling, where if the call fails, the error variable receives a value. Instead, if the function can throw an error, Swift requires that we add the keyword try before the call. By default, functions in Swift trap errors, but if we want to propagate the errors out of the function, we can include the keyword throws. However, in most cases, we probably want to handle our errors by wrapping them in a do-catch scope like this. We're going to be discussing error handling in depth in Section 6, Troubleshooting and Advanced Debugging. Before moving on, I'd like to mention that, as of December 2015, Swift has gone open source. There are many upcoming changes that we already know about. If you'd like to see the proposed and accepted changes for Swift 3, visit this video's resource page, where I'll be maintaining a detailed list of upcoming changes. In this video, we discuss the new additions to the Swift programming language as introduced in WWDC 2015. In the next video, we'll introduce the concept of functional programming.